All right, so we're going to work on lines today. So hopefully this will be familiar to you. Some formulas that you need to make sure that you know. And I'll make sure that these go into the PDF file that I do at the end. So if you don't get them copied, that's okay. I'm letting someone else join, so it will be just a minute. All right. And so first of all is our formula for slope. If you're given 2 points and it is change in y's, remember they go on the numerator, over change in x's. And then we have different forms of the equation of the line. The point slope form is the way that you find the equation of the line, and this software asks for it. A lot of times software doesn't ask for this particular form. They will go ahead to one of the next ones, but you'll have to enter both this time. So when they want point slope form, you will just have done your first plugins, and then you'll put that down. Slope intercept form is really your most useful form, I think. Isolate the y. So you're just doing some algebra to get to these different forms. Standard form we've used before. You get the x and y term on the same side, constant on the other side. I did see a general form listed a time or two or referred to in this material. I don't usually bother with general form, but if you see it, it just puts everything on one side and 0 on the other side. And you have to remember about special lines. Parallel lines have the same slope, and perpendicular lines have slopes that are negative reciprocals, so opposite sign and flip it over. To find your equations of the lines, basically what you need is a point and a slope. So whatever you have to do to get those things will help you to get the equation of the line. All right, so let's do some problems. And I started off with question 1, so it should be easy. It's going to use our first formula. And it wants us to find the slope of the line that goes through these 2 points. So we have 0, -4, -6, 8. They are asking us to find the slope. I would label so that it's easy to plug in. So if we call this one point 1, this will be x1, y1, and this will be x2, y2. So your slope is change in y's over change in x's. If you memorize this in the other direction, it doesn't matter if you do y1 minus y2, but you have to do the x's in the same direction. This is just the way I always have done it, but you would get the same answer. All right, so we plug in. So we have 8. All right, we're going to do minus a negative. I'll go ahead and write the negative, but you could clean that up at the same time if you want. And I have -6 minus 0. So this gives me a 12 divided by -6, which is a -2 for slope. And then they're asking us a question about understanding, right? And if this is a negative slope, remember it goes down as it goes to the right. You have to pretend like that's straight. It's decreasing. So slope is decreasing as it goes toward the right. All right. I put down question 2. I started to skip it, but I realized this one's going to be a special line, so we will have a look at it. It's again giving you 2 points and you figure out the slope. You could certainly go right into the formula that we just had. But if you notice it, your x coordinates are the same, right? And that means when you subtract them, you are going to get a 0. So if you remember, your y change goes in the numerator. So we're going to have our y change. So we're going to have some kind of number up here. But we're going to have a 0 in the denominator. What about that? This is an undefined slope. And undefined slope goes with a vertical line. And they're not asking us equation of the line yet, but it would be x equals -1. Right? So because those two were the same, that's why I could actually not go through the whole process. So here we would choose undefined, and this one is a vertical line. Next I went to number 5. So I don't want to bore you with all these that are the same kind. And this one says write the point slope form of the equation of the line, and then switch it over to slope intercept form. So we are given slope, so m equals -2/5. We're given a point. Right, and to get our equation of the line, that's the information we need. Go ahead and write your formula. Y minus y1 equals m times x minus x1. And you will plug in to the one with the subscripts. This is your point x1, y1. So we have y minus 17 equals m -2/5 times x. We're going to do minus and negative here. I'm going to go ahead and do plus. And this is what they want in the computer at this point for point slope form. So you've just plugged in, you haven't cleaned anything up. And so rather than type it, I just put that. All right, now they want to get slope intercept form. So you need to clear that fraction out. Multiply through by 5. And if you're great with fractions, you can distribute it, but then you're going to have to add and get a common denominator. That is way too much work. So I'll just clear the fraction out. And on this side, I have -2x minus 40. And over here, I have 5y minus 85. And now I have to isolate y to get the form they asked for. They asked for slope intercept form. So this was my first answer before I marked it up. And this one I'm going to isolate the y. So add your 85 to both sides. So 5y equals -2x plus 45, and divide through by 5. So I get y equals -2/5 x plus 9. All right, I'm dividing by 5. So this should be my answer in slope intercept form, -2/5 x plus 9. Any question? Right. This one I marked off. It's the same kind of work, except you don't have to clear the fraction. So it's actually less work than the one we just did. Right, so I did put 7 in my list. Let me have a quick look. Right, just ask a little bit different. And so it wants us to write the point slope form of the equation of the line and then slope intercept, but you're not given all the information that you need. So you are given points. Remember, you need a point and a slope. So you are going to have to calculate the slope first. So it's going to be your change in y's over your change in x's so we have -10 minus 8 over 3 minus 12, so -18 over -9, which gives us a +2. And so now we can write our equation of the line. So y minus y1 equals m times x minus x1. If you say that out loud every time you write it down, it will help you to memorize because you're hitting multiple senses by doing that. All right, so we're going to plug in, and then this would give us our first form. I'm going to just go ahead and use the point I called point 1. They will accept 2 different forms of the answer in the first one. So I have y minus 8 equals 2 times x minus 12. So this will be point slope form. All right, and so what you see here in the answer key is they would accept either this one, and it just depends on which one you call point 1, and this one, and they are equivalent. So this one was picking the other point as your point. All right, and so now we'll just clean it up and go to slope intercept form. We don't even have any fractions to clear, which is excellent. 2x minus 24. And so we will add the 8. So y equals 2x minus 16. Good. All right, next I picked number 9. And this one, the wording is just a little different. They are telling you that the line has an x-intercept at x equals -14. And it goes through 1, 9. What you have to know that's not said here is you want a point out of this. And remember, for x-intercept, the y is 0. So this is actually -14, 0. Always the opposite one is 0 on an intercept. And then you have the information that you need. So you need first to figure out your slope. Right, and we'll call this x1, y1, and x2, y2. So we have 0 minus 9 over -14 minus 1 is -9 over -15. They would expect us, of course, to clean up the two negatives and make positive, and also this will reduce with a common factor of 3. 3 will go into 9 3 times, and 3 into 5, 15 will go 5. So 3/5 for a slope. So our point slope form, so y minus y1, which is 9, equals m times x minus x1, which is 1. This should be our point slope form, right? And again, they gave us two different versions. Either one would be accepted. This is the one I chose. The first one chose negative 14, 0 as their first point, right? And then to clean this up, we would just multiply 3 by 5. That's going to cancel. So we have 5y minus 45 equals, distribute your 3, 3x minus 3, and then isolate your y. So you're going to add 45 and then we will divide by 5. And I don't think you can do anything to that. Good. Notice from either of those two versions, you end up just with one version for this form. Right. I did pick question 10. So things are worded a little different here. So they're giving us a function. And remember that f of x or g of x, whatever they have here, this is really just y if you get stuck. They have just put it in function notation. And at the end on some of these, they want you to go back to function notation. You have to get slope-intercept form to be able to do that. And then you just replace the y with the function notation. All right, so they want us to identify the slope. Easiest question you'll ever get because it's in slope-intercept form. So your slope is 5. Good. Showed up down here. All right. Y-intercept is also easy from this form. Y-intercept will be this number, and it doesn't say to write it as an ordered pair. So we could just answer -2, and that's what they're going to want. You probably, if you tried to type an ordered pair, it would say syntax error. All right, the last one's going to cause us a little more work. When they want the x-intercept, you have to set y equal to 0. Well, y is this whole side, and so you have this, and then we're going to have to solve for x. So we're going to add the 2 and divide by 5. And you can write as many steps as you need. So 2/5 equals x. And we're good there. And now they want us to graph this. Right, and we're not allowed to blow it up or anything. So we'll work with what's there. We will need the line tool. This is a line. And we will use the y-intercept and the slope. So -2 on the y-axis And then we're going to count with our slope. It will be a 5 over 1. So I'm going to go up 5 over 1. Right, here's our point we've got. So we're going to count up 5, 1, 2, 3, 4, 5 over 1. Click. That should be our line. Let's see if I put all these answers in so I didn't put any in. All right, so if I have the graph right, I should only get 0.25. And that's what I got. So the graph is green. All right, so we're good there. So let's see about 11. Same kind of question, really. They're giving you a function in function notation. But it is a line. Y equals 2/5 x minus 4. Right, so your slope, you read your slope right off. Slope is 2/5 because of the form you're in. Y-intercept, you can read right off. -4. X-intercept is going to make us work because we have to put 0 into the y. So 0 equals 2/5 x minus 4. Right, and we could check those. That was 2/5 and -4. All right. You can either clear your fraction here or move the 4 and then clear it. Doesn't matter, but you need to clear the fraction. So I'm going to go ahead and move the 4 to the other side. And I'm going to multiply through by 5 to get that fraction out of there. You could have also multiplied just by the reciprocal and it would actually have been solved. That doesn't work in all the cases, just when you just have the one piece. So I don't usually bother with that rule. So we divide by 2 and x equals 10. All right, so my x-intercept is 10. We're good there. And let's see if we can graph. Again, I would use the y-intercept and count with the slope. And it'll be okay even though our scales are small because we're going to start down here. All right, so we're going to start at -4. You're going to go up 2, 1, 2, over to the right 5, 1, 2, 3, 4, 5, and there is your point. And I just got 0.25 right again, but the graph was what I was really checking. Guys doing okay so far?
Yes.
Very good. This should be a fairly easy lesson for you, which is nice because the next one takes a lot of work. So sometimes it's nice to have a little breather in there. All right, so, and I just did 11, right? That's what we just did, yes. All right, so number 12. So they're giving us a different form. They are giving us standard form, which has x and y on the same side. And they're asking us the same kind of questions, except they want these intercepts as ordered pairs. The thing is, this is not the user-friendly type form. So you're going to have to do algebra on it first to get it into the form that you can use. So you need slope-intercept form. So even though it doesn't say that, that is what you have to do to get your information. So we're going to convert it. That means you have to isolate your y. So I'm going to add an 8x. And I'm going to shift slightly here. So 8x got added to both sides. I'm going to divide everything by 2. So y equals -4, and this will give us plus 4x. Now we can read off the information. All right, our slope will be the coefficient of the x. It doesn't matter here about the order. So m is going to equal 4. And y-intercept is -4. But they want it as an ordered pair. On a y-intercept, the x is 0. So we need 0, -4. Good. X-intercept is going to cause us a little more work. The easiest place actually to get the x-intercept is from the top line, because you're going to plug 0 into y, which is going to cancel this. Now you could do it right here, just like we've been doing, but we'll go back. So x-intercept just says set y equal to 0 and solve. This form, when x and y are on the same side, when you put 0 in to the y, it's going to cancel that piece. So we have -8x equals -8. Divide by -8. And so this is going to give us x equals 1. Now you have to answer as an ordered pair. On the intercepts, the opposite one is 0. So 1, 0. There we go. And the last thing on here is they want us to put it in function notation. And for function notation, you need to go back to where you isolated the y. This one will give us function notation. And they were calling this one h. So h of x will equal, and then we can just use the other pieces. So that's instead of y, -4 plus 4x. And this is the same. The order would not matter as long as you have the signs right. And then we'll draw the graph. All right. So let's see. I need my point. So I'm going to start at the y-intercept. I'm going to actually start with my line tool. And a -4 on the y-axis. And my slope is 4, so that will be 4 over 1 when you're going to move with it. So from here, let's see, did I go in the right place? So this would be 4 and over 1, and click. And we will check that one. So my graph was right, and these I didn't put in. You're good there. That's equivalent to what we had. It would accept what we had. All right, so that was 13. Next I picked 15. And I am not sure why I picked this. Oh, yes, I am now. It looks just like some that we have done. You have 2 points, and you have to find the slope. So you can write the equation of the line. And you could go ahead and go through the steps, but this one is going to be a special line because my x-coordinates are the same. And so the x-coordinates are the same in your formula. That is going to put a 0 in your denominator. And this one you're going to work it out. So 18 minus negative 19 would be plus, and so that would be 37. But that part's not going to matter because it is an undefined slope. Now, they didn't ask us about that. Actually they did. All right, so we're going to answer undefined. And they want the equation of this line. So this is, you have to kind of think outside the box when it's going to be these special lines. You need to remember which one gets an undefined slope. It's a vertical line. And a vertical line is of the form x equals some constant. Well, the number that's used in the x spot is -1. So x is always -1, and the y changes. So you're not really able to plug into any formula because your slope is undefined, so it doesn't go into the formula. But you can go outside the box to get that. Right, and if you had the one with the y's being 0, the y's being the same, giving you 0, it would just be y equals whatever constant that one was that was the same. Okay. So it's not a hard question, it's just a little different than what you've been asked before. All right, and so I did look at one here, 16. And this one, they are giving us a special line. We know it's special because it only has one variable. And this one is y equals something, so this will be the horizontal line. And its slope is 0. So you're going to just remember that. So you want to say 0, you don't want to say undefined. Your y-intercept, so on a y-intercept, your x is going to be 0, but your y always has to be this. So you have to think a little bit on this one. It will be, let's see, y will always be this. The x will be 0 on a y-intercept. So 0, -13/2. And it's not saying anything about an ordered pair, so I'll enter this one. So -13/2. And then it asks about the x-intercept. Right, so y is a horizontal line, and -13. So this is going to be about -6.5. So it is going to be like right here. All right, and it's asking for x-intercept. Right up here is your x-axis. It is parallel to the x-axis, so it is never going to cross. So there is none. So that would be one way to approach that question. Definition of x-intercept is the y has to be 0. Well, this says y can never be 0. It's always this value. So you could also go that thought process and you can say it does not exist. So there is not an x-intercept. We are actually parallel to that. I'm going to try to draw this one. And when you do try to graph, a mixed number is much easier to graph with than this. Divide it. And you can get the decimal if you use your calculator. So it's going to be negative, but 13 divided by 2, and it will give you 6.5, negative 6.5. Well, you have to enter it right. 6.5, okay. And negative, I didn't put the signs in. All right, so when I graph it, I'm going to be in between, and I'm going to just hope that it's nice. So negative 6, so a little more than negative 6. So like here, and this one I want to line straight up. And hopefully it will accept those. Fractions are harder to graph and deal with. Good. So you were able to get that. But it is definitely easier to switch that to a mixed number. When you're drawing your graph. Right, I did pick 18. Right, and so again, we have a special line. So this whole little section right in here is special lines. We know it's special because it only has one variable. And so this one is going to be the vertical line through x equals negative 6. If you forget that, you can always go back to your little table and make yourself a picture. To remember, vertical line, the slope is undefined. Y-intercept. Y-intercept says that the x has to be 0. X can't be 0. So there is going to be no y-intercept. You could make yourself a little picture. And this is our line. And it does not cross the y-axis. So it does not have an y-intercept, sorry. So there is no y-intercept. For the x-intercept, the y is 0, but it is still going to be x will equal negative 6. And they didn't ask for an ordered pair. If they did, it would be negative 6, 0. All right, and they ask us to sketch the graph. So hopefully you remembered that it is a vertical line. And I'll go to my negative 6, and you just need to click 2 points. This one will be easier than that other one because it's not fractions. Very good. All right, then I skipped to 24. And this is where they start talking about parallel and perpendicular lines. And so from our first page, remember parallel lines have the same slope. That's important. Right, and so they're giving us a picture this time, and the solid line has this equation. I'm just going to switch that f of x to y. All right, the dashed line is parallel to it, and so we want to determine the point slope equation of the dashed line. Well, to get the equation, you need slope and 1 point. Since you know the slope of this line and that it's parallel, your slope will be the same. So our slope will be -4, and you need a slope and 1 point, and they have put a point on so that you can tell. And so it is -1, -2. So you need the coordinates of that, and then you can do your formula. So it is y minus y1 equals m times x minus x1. We need to make a song with that, huh? All right, so this will be y minus a negative makes plus 2 equals -4 times x minus a -1 makes plus 1. This is the first thing to go in. So y plus 2 equals -4. What did I copy wrong? No, oh, I got the coordinates of that point wrong. Sorry. Right? That's on the positive side. +1, -2. All right, so you have to backtrack. And that would change. Let's see. This piece. Because that was the x, and so it would be x minus 1. Sorry about that, guys. I just read the coordinates off wrong. All right. So we're going to change it to slope-intercept form. Standard steps here, isolate your y. This was point slope form. And we're going to subtract 2. So y equals -4x plus 2. Good. And now they want us to write function notation. Comes right from here. All you're going to do is put g of x. Excuse me. Sorry. Equals -4x plus 2. There you go. All right, have one more picked. Okay, and this one's given us perpendicular lines. And perpendicular lines have slopes that are negative reciprocals. So our solid line is f of x equals 3x plus 5. It is perpendicular to the dotted line. So this one's slope is 3. Our slope, or the dotted line slope, will be opposite sign and flip it over. M will be a -1/3. So that's what you get from knowing that the lines are perpendicular. You need the slope and 1 point. So they have given you a point here. We'll see if Miss H can pick the right coordinates this time. -1, -2. And we just took that from the graph. And then we can write the equation of the line. So y minus y1 equals m times x minus x1. So y, this will be plus 2 equals -1/3 x, and this should be plus 1. This is your point slope form before you clean anything up. Good, no errors there. And then you want slope-intercept form. So you're going to clear out that fraction. Multiply through by the common denominator. This one cancels. So we have 3y plus 6. You have to just watch your algebra a little bit here and don't forget to distribute that negative. Right, and now we need to isolate the y. So we're going to subtract a 6. So we have negative x minus 7 equals 3y. And we're going to divide by 3. So y equals negative 1/3 x, pulling that coefficient away from the x, minus 7/3. Good. And for function notation, and they're telling us g this time, just put that instead of x, instead of y in this form. Negative 1/3 x minus 7/3. Very good. All right, let me look back. I had one that I put a star by if there was time. So, maybe we did it. 18, did we do 18? We did. So we're good there. All right, so that's our lesson for today. This one should be pretty easy for you. I am not going to be here on Thursday. So Thursday, you're going to have no session. I have a recording from last year, so I will put it up there for you guys. I will warn you ahead of time that that lesson is harder from the work. So before you do it, so I'm just kind of preparing you. Before you do it, make sure that you watch your videos and take your notes from the note templates. And there's 2 pages that are real important. And let's see if I can get into our class. So from your packet, most of you guys have a packet. It will be, I believe, page 39 and 40. And I'm going to pull them up, I think. We are in chapter 3. It'll take me just a second because I have to go to a different screen. All right, yes, so let's see if I can pull these up down here. So in this section, all right, come on. Good. You're going to have some graphs that you should memorize. And not real user-friendly there, huh, with that? Let's see, can I go a little bit bigger? All right, so this is page 39. And you want to memorize these. The first 2 I don't usually bother to memorize because you can figure them out. And for your transformations, what you're going to do is transform all these ones in these 2 pages into different graphs. You're going to do different things to them. And but our first one is just a horizontal line. And this goes through, you know, it's going to be y equals some constant. It talks about its domain, but you could pick that from the picture. Its range is only going to be that one value. It is constant, and it's an even function because it will flip across the y-axis and look the same. But I think that you could figure that one out and not have to memorize. So I don't memorize that one. I don't memorize the next one, even though it is an important one. We will use it more when we do inverses, but it is called the identity, and it goes through 0, 0, and it's the line where all your coordinates are the same. So your x's and y's are the same. So like to draw it, you want 0, 0, 1, 1, 2, 2, negative 1, negative 1, negative 2, negative 2. So you can always create it fairly easily, right? And your equation is just y equals x, right? And so its domain, it goes forever, range, it is always increasing because increasing, decreasing, remember you look left to right. And this one is an odd function because if you rotate it 180 degrees, you're going to have the same picture in this quadrant here, right? And that means it's symmetric around the origin, around 0, 0. All right, so what we'll look at are some of the others, and hopefully I put this in the other video because I teach it in class, so I assume that I did. But this is the absolute value graph, and it's important to be able to create that graph yourself because you're going to do things to it. Even though you're going to know, okay, absolute value graph is going to look like a V, you want to know what kind of points to pick. So if we have, so we are on page 39 from your packet, and we are looking at f of x equals absolute value of x. And we know it looks like this. But to make your table, if you were going to draw this picture, if you didn't know what it looks like, you want to make sure, because you're not looking at a line, you need some positive, some negative, because you want to know, well, what does it do to negative numbers? And you want a 0. So the points I would pick are 0, 1, 2, and negative 1, negative 2, and that would make your table. So absolute of 0 is 0, absolute of 1 is 1, absolute of 2 is 2, absolute of negative 1 is 1. So it turns these negative numbers back into positive. And that would give you your nice graph for this one. And this one, when it is centered at the 0, 0, this is your vertex, then it is symmetric around the y-axis. It would flip across, so it's even. It has increasing and decreasing, so you're going left to right. This piece is decreasing. I should use my mouse because it shows up on there. I noticed when I use my stylus, it does not show up on the video. So on the left here, this side is coming down to 0, that's decreasing, and then it starts up, that's increasing. So it has both, right? The parabola. Next one is a standard graph parabola, and you're going to use the same chart really as we did absolute value. So y equals x squared, always going to give you a parabola. If you haven't done things to it, it's going to look like this. And for your table to make it, you want 0, 1, 2, and you want negative 1, negative 2 to see what happens to those. So 0 squared is 0, 1 squared is 1, 2 squared is 4, negative 1 squared is 1, and negative 2 squared is 4. So it's going to change those negatives to positive. This would get your standard one. These are also called the parent function in the transformations that you'll do in that section. Right, so that one is pretty easy to pick out, and it behaves like the absolute value as far as being even, flips across the y-axis as long as the vertex is at 0, 0, and it has a decreasing and increasing. Right, the next couple, you have to be a little more careful with your choices to make your table if you're having to draw it yourself. So if I have f of x equals square root of x, right, and this is what it's going to look like. It has the little curve, right, its domain is restricted, so you're not going to have any negatives on it, but but let's make the table so we could draw it by hand if we needed to, right? So you can have a 0 in here. Square root of 0 will be 0. You can have a 1. Square root of 1 is 1. Right? Now, you want to be careful what you pick for x here, because if I pick 2, square root of 2 is a decimal that goes on and on. That's not a very nice number. So what you want to try to get is a perfect square. And our first perfect square to help us get this would be a 4. The square root would be 2. And then your next perfect square would be 9, and the square root is 3. So if you were graphing by hand, right, so we would have 0, 0. We would have 1, 1, 4, 2, and 9, 3. So it looks like that. And just your characteristics. This one, your domain, the leftmost point is going to be 0. It is included. So up here, your range is also going to limit, it's going to be bounded at 0. So 0, this actually will go up forever. It's pretty flat looking line, but as it goes out, it does go up, right? It is always increasing. And this one is neither even nor odd. It does not flip across your y-axis. And if you rotate it, it's not going to give you the same thing down here as you had up there. Right? But just drawing it yourself, a little different. Okay. Next one is our cube graph. And so we have f of x equals x cubed. Sorry about the color. Switching that up there. And so you want to try to remember kind of how it looks. Going to be like that with a curve. Of course, you can pick 0. You can pick 1. You can pick 2. And -1, -2. So standard points there I would pick. 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. Any bigger than that, 3 cubed is 27. It's way off. Right. -1 cubed is going to give you -1. So you're still going to get the negatives here. -2 will give you -8. All right, so that would help you get a nice cube graph. The last one we have in our ones to remember, this one is harder for me. This is the one that I have to be careful with because I mess it up. And this is the cube root function, which is the inverse of the one we just had. And so when you make your table, you want to pick perfect cubes because you're going to do a cube root. Now, cube root, you can pick negatives, right? So it is not limited like a square root. So we can pick, of course, our 0, right? We want a perfect cube. So 1 is okay, right? But then your next perfect cube is 8 because the cube root of 8 is 2, right? And then do -1 and -8, and that will give your value. So cube root of 0 is 0, cube root of 1 is 1, cube root of 8 is 2, cube root of -1 is -1, and cube root of -8 is -2. And that would help you get your graph. I have to look back at this one all the time, or recreate it because I mess it up. All right. So go through the notes on that and that video, and it's a little long. There might be a couple of videos for it to get through them, but you have a good start there. And when you get to the homework, it starts out with the hardest questions. Let me see. Let me get rid of this picture. I'll just look at one and then I'll stop, I promise. All right. Hopefully they don't give me the hardest one first. That would be really rude, huh? I'm not going to do that one. All right, so when you go through your other things, so this, I'm talking just a little bit ahead, but it does give you the hardest questions first in this section. It gives you a picture and it wants you to say how it has changed the parent function, which is one of our pictures we just had, to get over to this picture, and what you have done to it. So I know that you guys haven't reviewed this part yet, but we'll just look at this one, okay? All right, so your parent function here, this is a parabola, and this side will go on. So your parent function is f of x equals x squared. All right, and we're good there. All right, and you notice this one's moved because our parent function and we made our table and its center is 0, 0. Is this. So 0, 0, 1, 1, and 2, 4. And once you get one side of it, the other side's going to look the same because it is an even graph. It's symmetric on the y-axis. So that's our parent function. And it has moved over. Look at the vertex to help you figure out how it's moved. So watch this point. It has moved over to the right 1, 2, 3, 4. It's moved right 4. So 1, 2, 3, 4. But it's also moved down 1, 2, 3, 4. And down 4. Right? And so the way you show that on the equation is a up or down movement goes separate. It's going to go out here and it will do exactly what it says. So if it's down, it's going to be negative. So this is your moving down. Right? The left and the right, moving it across, just sliding it, goes in with the x. So I'm going to have x, and you write the opposite for the x. So it shifted to the right 4, so I'm going to do a minus 4 in here because left and right is opposite. Keep your parentheses, square, and this minus 4 on the outside is your vertical movement. So vertical movement does exact, and it's outside. Horizontal movement does the opposite. And it is on the inside with your function. And then they just want us to type that. And you would not multiply this out. You would put it just like that. All right, I'm going to stop there. I am sorry I have to go away on Thursday, but I'll put the other video up. And I messed up one of the problems in it, so you can laugh at Mrs. H. But I had a real active student in there. So it's a good video, and I worked the problems just like I would do on here. So I will put it up for you guys. And any that you run into, and I just warn you that something's going to be a little harder so that you won't get frustrated. So when you work on it, if you get stuck, it's okay to get stuck. and just we'll take time and go back to anything on next week's class on Tuesday when I come back. Okay. All right. So you guys have a great day, and I'll see you soon. Today's homework should be easy.
Thank you, Mrs. H.
You're welcome. I'm going to turn this recording off, but I will hang out here.